We are moving into a whole different unit here and talking about a different topic. It's still going to relate back to polynomials. We're going to have to use it on polynomials, but we're talking about factoring this unit. And factoring, as we'll see, is a way to break things apart. So we talked about in the very last lesson dividing polynomials. This is sort of a subsection of dividing polynomials. It's a different way to divide polynomials into their different pieces. When we talk about factors, what we're really talking about are what things can we divide something by. So since we could divide 6 by 1, we could divide it by 2, we could divide it by 3, we could divide it by 6, all of these are factors of 6. If I said 6 equals 2 times 3, I would say that I have factored 6 into 2 and 3, into two pieces, 2 and 3. Sometimes there's different ways to factor things, right? So in this case, 6 equals also 1 times 6. I factored 6 into 1 times 6. It's not always unique. Typically with polynomials, we are going to find a unique answer, but that is not necessarily always true. So what we're looking for is the two things that make up something that we start with, right? So we start with a number or we start with an expression. We might start with a polynomial, and we're trying to break it into its separate pieces. The way that we're going to start factoring is with greatest common factor. This is the best place to start because we're going to need the GCF to do other types of factoring. Greatest common factor is often abbreviated as GCF. GCF for greatest common factor. So just like in the last example, since 2 times 5 equals 10, that means 2 and 5 are factors of 10. If we want to find the greatest common factor between two numbers, then we're going to find all of the factors of each numbers and try and find all the ones that are in common, right? And then specifically, we're going to try and find the greatest one that is in common between those two items. For example, if I'm trying to find the greatest common factor of 24 and 36, the strategy that we're going to use, here, let's say that we're ignoring B for a moment, okay? So for A, if we're trying to find the GCF of 24 and 36, the way that I like to do this is with a factor tree. 24 breaks into 2 and 12. 12 breaks into 2 and 6. 6 breaks into 2 and 3. Then we're going to list all these prime factors out in numerical order. Notice that once I got to one that I could not break down, I circled it. So 2, I can't break it down any further. 1 times 2 is not doing me any favors. Same thing with 3. All right, 36. There's more than one way to factor this. I'm going to go with 9 times 4. 9 is 3 times 3. 4 is 2 times 2. And let me just show you something real quick. I'm going to go down here and do some scratch work. What if I had started with 36 and done instead, let's see, 2 times 18. All right, 18 is 9 times 2. 9 is 3 times 3. And notice I still came out with the same exact prime factors. No matter which way I started, you should end up with the same exact prime factors. All right, to find the greatest common factor, what we're going to do now, let's list out our purple ones in numerical order. 2, 2, 3, 3. I'm going to look for the ones that they have in common. So they both have a 2. They both have another 2. And they both have a 3. Notice that this 2 and this 3 are not in common. So the things that I have in common are 2 times 2 times 3, which is 12. 12 is my greatest common factor. The more of these you do, the better you're going to get at doing them. So once you have done several of them, you're going to be able to skip that factor tree. A lot of people will be able to skip the factor tree. 12 being the GCF, what that means is 12 is the biggest number that I could divide 24 by and also divide 36 by. I could divide 12 and 36 by 12. I'm sorry, 24 and 36 both by 12. 12 is the biggest thing I can divide them both by, the greatest common factor. Let's try B here. 104, 40, and 60. So I'm going to block this off. This was A. Now for B, I'm blocking it off so I can use the same colors here. 105. What can I divide 105 by? It has a 5 on the end. That means you could probably divide it by 5. And 105 divided by 5 is 21. 21 breaks down into 7 and 3. So my factors here are 3, 5, and 7. I'm putting them in numerical order, smallest to biggest. 40. I can break it into 8 and 5. 8 breaks into 2 and 4. 4 breaks into 2 and 2. So my prime factors are 2, 2, 2, and 5. And let's choose another color for 60. 60 is 12 times 5. Again, it doesn't matter which way you started. You could have done 6 and 10. 4 and 3 makes 12. And 4 is 2 and 2. And so all together here I have 2, 2, 3, and 5. Notice my prime factors, if I multiply those back together, 2 times 2 times 3 times 5, I do get 60 back. That's sort of a midway check to make sure that you're doing things right. Now between all three of those, do I have a 2 in common? Nope, that blue item does not have a 2. What do they all have in common? They all have a 5. And let's look for anything else. There's not a 2 in common, there's not a 3 in common. So my GCF here is just 5. 5 is the biggest number you could divide all three of those items by. All right, take a second and try these, 12 and 20. You can pause the video. The greatest common factors of 12 and 20. 12 breaks into 2, 2, and 3. 20 breaks into 2, 2, and 5. So if I'm looking for my greatest common factor, 2, 2, 3, 2, 2, 5, they both have a 2. They both have another 2. The 3 and the 5 don't match, so 2 times 2 equals 4 is the GCF. Again, pause and try this one. 45 breaks into 3, 3, and 5. 75 breaks into 3, 5, and 5. 30 breaks into 2, 3, and 5. So here if I have 3, 3, and 5, 3, 5, and 5, 2, 3, and 5, what do they have in common? I see a 5. I don't see anything else that they all have. Oh wait, they have a 3. That has a 3. That has a 3. So 3 times 5 equals 15 is the GCF. All right, find the GCF. This time we have variables as well. Here's what we're going to do. We're just going to do one of these. We have some more practice of this on the next slide. I just don't want my slide to get too cluttered here. So if I had 7x to the third, I would try and break down the 7. We notice that the 7 cannot break down, so we're just going to leave it as 7. The x to the third, though, I'm just going to write that as 3 x's. All right, 14x squared. 14 breaks into 7 and 2. Both prime, so I'd have 2, 7. That's 14x squared, so I'd have an x and an x. All right, the 21. X to the fourth. 21 breaks into 7 and 3. That's 3, 7, and 4 x's. And let's try and find what they have in common. They have a 7 for sure. They have an x in common. They have another x in common. And nothing else, right? Because the middle term doesn't have another x. They don't all have a 2. They don't all have a 3. So 7x squared is the GCF. Here's another couple of examples for you. Try this first one, number 3. I'm about to show you what I wrote. So for 10z to the third, that breaks into 5, 2, z, z, z. 15z to the fifth breaks into 5, 3, z, 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 z. 40z breaks into 2, 2, 2, a 5. I'm missing my 5 in there. Let's see here. 2, 2, 2, a 5, and a z. All right, let's find what they have in common here. They all have a 5, right? They all have a 5. They all have a z. Do they have anything else that they all have? They don't all have a 2, so it looks like the GCF is just 5z. Here's another to try. This is what the first breaks into, and the second. If I'm looking for what they have in common, they both have a 3. They both have a y. They both have another y. They both have a w, and a w. So what I have circled down here, in common, they have a 3w, w, w, y, y. That's 3w to the third, y squared. Hopefully you're getting good enough at these that you're not having to write out that factor tree every time, and you can start to recognize, the more of these you do, you start to recognize that the GCF between 6 and 21 is 3, right? And then you can look at your variables. I'm going to leave it to you to find a shortcut here to see how you're going to figure out how much of which variable to take out. All right, so far we have just found the GCF for some items, right? So here's another example. This one, you may want to use your trick. See if you can use the trick that you figured out from the last slide. So we've got 2's in common. We've got C's in common. We've got D's in common, but not E's. So I have 2c squared d to the fourth is the GCF. All right, we have seen how to find a GCF. Now we need to look at how to actually factor out a GCF. So far we have just identified the greatest common factor. This is another where we're trying to identify. It just looks a little different. We want to find the greatest common factor. And if we look at these without breaking them down with a factor tree, we can see that they both have this thing, right? It's the same thing in both, that a plus b. And that is the greatest common factor. They don't both have a 3. They both don't have a y or an x, but they do both have an a plus b. So the GCF here is a plus b. All right, when we're trying to factor out a GCF, it's almost like we're trying to undo the multiplication. Just like I said earlier, 6 equals 2 times 3. We're trying to find what multiplies to get the original problem. So what we did in the last unit was we multiplied and distributed to get an answer. What we're trying to do this unit is take the answer and break it back apart into its multiplied pieces. We're trying to undo the multiplication. The way that we're going to do that is the same way we have been doing to identify the GCF. We'll identify the GCF the same way we have been doing. We'll write the GCF down, and then we will divide it out of each component. For example, if I have 4x minus 20, what is the GCF? Take a second, pause, and try and identify the GCF between 4x and 20 the same way we have been doing. If you broke them into a factor tree, you would have a 2 and a 2 in common. That gives you 4 as the GCF. Here, let's do that just for this one example. So for this item, 4 breaks into 2, 2, and x. 20 breaks into 2, 2, and 5. This is what they have in common. So 4 is the GCF. So we find the GCF, we write it down. We open a parentheses. We're going to maintain the fidelity of the signs in here because we're taking out a positive 4. We know we're going to have a minus, and there's 2 items here. So we're going to have a minus between those 2 items. If I divide the 4 out of the 4x, what's left? And if I divide the 4 out of the 20, what's left? So that is done. We have factored out the GCF. Which is 4. We'll do that whole process one more time. 6w squared, that breaks into, with our factor tree, 2, 3, w, w. 3w just breaks into 3 and w. 3 and w. What do they have in common? Looks like they have a 3 and a w in common. If I take the 3w out and write it down, remember to maintain the fidelity of the sign, that's a plus there, because I'm taking out a positive 3w, I'm not going to change that sign. If I took the 3w out of the first one, what's left? 2 and w. If I took the 3w out of the second one, what's left? Nothing. So if I divide 3w by 3w, you're just left with 1. You can always check back to see that you did this right by distributing. We're not going to do this every time, but just here, let's just check it, right? This is our solution. If we distributed this back in, 3w times 2w would be 6w squared. 3w times 1 would be 3w, and notice that that does give us back our answer. That is a way to check it. All right, take a second, see if you could find the GCF. The GCF between 6 and 18 should be 6, and if you take that 6 out of the first one, you're left with a w. We have a plus in between. Take the 6 out of the second one, and you're left with a 3. That is factoring out the GCF. That's all there is to it, factor it out the GCF. For the second problem down here, 21m to the third minus 7m. Find the GCF. They both have a 7 and an m in common. And if I took the 7m out of the first one, I would have 3m squared, right? 3mm. If I took the 7m out of the second one, notice that there's nothing left there, so we would just call that a 1. And notice I maintained the sign in between. Take a second and try this one. I would pause the video and see if you could do it. The GCF will be 3y to the third. And if you took it out of the first one, you'd be left with just the 5. And if you took it out of the second one, we'd have a 2, and a y. That's 4y. Notice we're multiplying the things that are left. Let's try and shortcut this next one without doing the factor tree. If you need to write down the factor tree, then absolutely do it. The GCF between all three of those is going to be 9, a to the fourth, b. And if you divide that out of the first, there will be left a 1 minus 2a plus 3a squared. That should be our answer. Hopefully you're getting good enough to shortcut some of these, because we're going to need this when we get ready to do our next type of factoring. You can factor out a negative factor. On all these, remember I was saying that since we were taking out a positive factor, our signs don't change. If we were to take out a negative factor instead, it actually changes the signs of everything. So dividing a negative out is going to change the sign. Negative 3x squared, dividing a negative 3 out, we'd be left with a regular x squared. And I know that because if I distributed back, I would get what I started with. Negative 3 out of positive 6x is going to be a negative 2x. Negative 3 out of negative 33 is going to be a positive 11. Notice the signs changed in every single one of those items because I was taking a negative 3 out, essentially dividing by a negative 3. All right, this goes back to the binomial factor. We have to look very closely. What do these have in common? They don't have a 2 in common. They don't have a w in common. What do they have in common? They have that x plus 3 in common. So if I take the x plus 3 out, what do we have left? A 2w and a minus 5. And that, we just factored out the x plus 3. Try the same thing here. We're going to have to use this in just a second. They have an a plus b in common. And if you take it out, you'll be left with an 8y and a plus 9. All right, we're going to try and organize this chart as we go. So the first thing for any problem, and the reason that we did this first is because the first thing for any problem is we're going to try to take out a GCF always. Unless the problem specifically tells us factor by so-and-so, factor by grouping, factor by AC method, unless it tells us a method, we're going to try to take out a GCF first. After we take out a GCF, we're going to look and see how many terms the polynomial has. So if I look at something like 8x to the fourth minus 9x cubed, that's 2 terms. That's 3 terms. That's 4 terms. Depending on how many terms it has, we're going to choose a different type of factoring. And so for us today, what we're looking at specifically is GCF. We've already factored GCF. And then we're going to look at four terms. The way you factor anything with four terms, or try to factor anything with four terms, is by grouping. You're going to try to factor four-term items by grouping. Let's see what that looks like. So factoring by grouping. Again, last unit we talked about multiplying polynomials. And when we multiply polynomials, we have to distribute every item. What we're trying to do is take a four-term polynomial. Notice this has 1, 2, 3, 4 terms. And we're trying to break it into two binomials. The way that we're going to do that is by grouping the first two items and the second two items. For the first two items, we're going to factor out a GCF just like we have been. So the GCF of the blue underlined items would be 3a. And if I factored that out, I would be left with x plus 4. You could take a second and try and convince yourself of that. You're going to keep the sign in the middle. And then you're going to do the same thing for the purple group. The GCF of that purple underlined group is 2b. And if you factored it out, you'd be left with x plus 4. The key that you need to recognize here is now we're left with a very similar problem to what we just did 2 slides ago. These have that x plus 4 term in common. That is the same in both. So we can actually take that out and be left with 3a plus 2b. That is factoring by grouping. We took a polynomial with 4 terms and we broke it into two binomials. That's two things with two factors with 2 terms apiece. Let's do another one of those before I let you try one. I would look at this problem and I would say, how many terms does it have? Well, first I would look at it and say, can we factor a GCF? 5, 10, 2. There's not a GCF between all the items, but I'm noticing this has 1, 2, 3, 4 terms. Anything with 4 terms, I'm going to try to factor by grouping. Our problem actually says factor by grouping, so that's a good sign. For the blue group, the GCF is 5, and if you took it out, you'd have x plus 2y. I'm going to keep the sign in the middle, and the GCF of the second 2 terms is a, and if you factored it out, you would have x plus 2y. This is your checkpoint. If you're factoring by grouping, you really want these 2 parentheses to match up so that you could factor them out. Since they match up, you could factor them out and be left with 5 plus a in the second parentheses. Notice grouping, all we're really doing is factoring a GCF 3 times. We're factoring a GCF out of the blue group, factoring a GCF out of the purple group, and then factoring out that GCF that is the common binomial. Here's another couple. Let's do one of these. There's no like term between all 4. There are 4 terms total, and so I'm going to try factoring by grouping. For my blue group, I could take out an a. This time we have a minus in between. For the purple group, it seems that there is nothing to take out. If there's nothing to take out, we'll just say we're taking out a 1. And now since I'm taking out a negative 1, it's going to change the sign of every item. Notice now that I did that, I've got a binomial in common, an x plus y in both. And if you take the x plus y out, you'd be left with a minus 1. Pause your video and try and do the second one. Here's what the first step should look like. And here's what your last step should look like. All right, again, pause the video and see what you could do here. There's 4 terms, so we'll factor a blue group and a purple group. The 2w minus 5 is in common, so you could factor it out to the front. Same thing here. Pause the video and try this. Since there's 4 terms and it says factor by grouping, with the typical problem, I would try and take out a GCF, and here you actually can. Since the problem says factor by grouping, we're going to go straight to that, make a blue group and a purple group. And since the a plus 2 is in common in both, we could factor the a plus 2 out. And that's the last problem here. What we're going to do for the next several lessons is try and fill in that chart. I showed you a few slides ago the factoring chart, right? And it was broken up by terms. And so the next thing that we'll look at is factoring things with 2 terms and 3 terms, right? We've done GCF and we've done 4 terms. We need to look at things with 2 terms and things with 3 terms.